Okay, hi guys. Thanks for coming and chatting with us. Do you want to just start by introducing yourselves?
Sure. Hello. I'm Mert Cemri. I'm a third year PhD student at UC Berkeley. I'm co-advised by Ion Stoika, Kanan Ramchandran, and Alex Demarkis. I'm working on machine learning systems. In particular, how can we make test time compute faster, more efficient, and more performant?
Hi, I'm Melissa Pan. I'm a second-year PhD student, also from UC Berkeley. I'm advised by Matej Zaharia, and then what I'm working on is like between systems and agent. Particularly, how do we make it run more efficiently, more sustainably, and then like more reliably?
Cool. Do you want to tell us a little bit about what you've been working on or presenting here at NeurIPS?
Why don't you go?
Okay, yeah. So basically, people say like 2025 is the year of agent, and I guess at this point we can kind of tell that it's true. It has shown a lot of fascinating capabilities. And then when we look at agent in the real world, it's usually in the form of like various form of like multi-agent system. But then when we take a closer look at multi-agent system, we find out that they actually fail very frequently. So for our study that's presented at NeurIPS, we want to set out to understand why do multi-agent systems fail in order to build like more reliable system going forward.
So we talked about we work on test time compute. How can we make these language model agents think better without changing its parameter weights, without doing training? And there can be multiple ways of doing this. For example, you can let the agents think more and more. You find their own thoughts, as in chain of thoughts style prompting, or you could sample n times from the same agent and pick the best one, as in best of n sampling. However, the way we see it is the multi-agent LLM systems are like generalizations of these test-time compute paradigms. For example, instead of the same agent refining its thoughts over and over again, you can have multiple agents refining each other's thoughts. Or instead of the sampling n times from the same model, you could have n different agents and then sample different things from them based on their expertise. So we were interested in analyzing multi-agent LLM systems, and there are indeed, just like this thing I explained, there are other many good reasons of why you should use multi-agent systems, such as you might want to manage your context better, maybe your documents are very long, maybe you are looking at a very complicated task, maybe it's a good idea to decompose it into multiple chunks so that each chunk is more digestible and LLMs have a better chance at solving them. But when we were analyzing multi-agent LLM systems, we found out that they have very interesting and different failure patterns compared to single agent use cases. For example, when you ask a complicated question to a multi-agent LLM system, sometimes different agents talk too much with each other, they derail from the original task specifications, they end up doing something completely different. Sometimes they don't listen to each other, sometimes they hide crucial parts of information that are vital for the successful completion of the task from each other. So, as Melissa said, we wanted to standardize the way we annotate multi-agent LLM systems. So we put forward a taxonomy of 14 different failure modes, such as failure to elicit clarification, task derailment, agents disobeying their roles, etc. And we'll be presenting it as a spotlight poster tomorrow at 11 a.m. here in San Diego.
Yeah, cool. I guess something I'm kind of curious about is when you guys sort of run these experiments, are you assuming that all of the agents are like incentive compatible, or like they're all trying to solve the same problem? Or are you looking at maybe, like you mentioned, some agents are like sneaky and they don't share all the information? Is that sort of an emergent thing that happens despite them being aligned, or are you trying to look at what happens when maybe there are misaligned incentives?
That's a very good question. So in more theoretical computer science or in game theory, I know there's like very interesting body of literature on adversarial agents or some like Byzantine robustness in decentralized settings. But in our case, all of the multi-agent LLM systems that we analyze are collaborative. They are trying to solve a common problem by decomposing it into multiple different parts. Some agents might be, for example, writing code. Some other agents might be trying to review the code. Some agents might be, for example, internet search to get relevant literature. But at the end of the day, all of the systems that we are looking into are collaborative. They are not adversarial, or at least the assumption is that there is no emergent phenomenon that would make them compete against each other, given that we ask them to solve a problem together.
And also just to add, like we study like across 7 open source multi-agent systems that are like out there, like built by people who are like serious about building multi-agent system. And then we like analyze them on like 3 very common tasks, which is like coding, math, and then like general QA. So yeah, so like these are all trying to solve like these tasks together, and then they organize agent in different way, like based on whichever like framework that we are looking at. So I guess just to answer your question, like they are trying to solve the same goal, but different agent may have their own like subtask.
Yeah, that makes sense. I'm curious if there's anything while you were sort of in the exploratory phases of this project that didn't end up making it into the paper. Like whenever I write research paper, there's like random stuff that like doesn't end up going with the story.
That's actually a very good question, because like initially we actually did a bunch of like exploratory multi-agent. We actually tried to build our own multi-agent system initially, like say do chess. We have like our own hacked up versions of like hotpot QA agents, like having partial information and all of that, or like tutor math agent and like a student agent. But like we found out that these are very like toy setting, and we want to understand like what are like the real problem that exists in real multi-agent system. That's why we ended up trying to like find existing like open source multi-agent system to like work on them. So like all of our work that went into like building these like initial multi-agent system didn't ended up like making to the main paper.
Yeah. Are you trying to pick them back up like once you have this framework out? Now you have sort of the tools or the language to revisit the old system that you were building? Are you trying to, or are you letting that be in the past?
Well, I mean, I guess Mert can comment more on your part, but like I do have other project right now where I'm like kind of also building my own agent, but it's like not the same type of agent. But I definitely did pick up like insights and knowledge from that process. Yeah.
So the main reason why we omitted that initial toy agents from the paper was that we did not want to include actually any toy examples that we were building. So for example, what we did was we really took some single agent use cases and artificially made them multi-agent, and we disturbed the original task. For example, made agents have partial information instead of having full information. But in a nutshell, with our advisors, we concluded that let's take the very popular, well-regarded multi-agent systems out there, let's analyze them strictly and build our taxonomy. Now, having built a taxonomy, one question is this: what does it mean that our taxonomy is good? In particular, what taxonomy buys us is a way to evaluate multi-agent LLM systems, and in fact, we can really evaluate any compound AI system. Compound AI system meaning that when AI agents are using some tools to interact with the world, or there are multiple agents talking with each other to solve some task together. Now, the question again arises: what does it mean that our evaluation method is good? Why do the failure modes in our taxonomy matter? So one thing that we are working right now on, and we have some positive results about this, is that if we build some initial crude agentic system to solve some tasks, some real world tasks, and we optimize it according to our taxonomy, according to our evaluation tool, the task completion, the downstream task accuracies of these agentic systems also do improve. Back to your question now, are you working on building your agentic systems? Yes, and the way we do it is, so using the existing agentic systems, we built our taxonomy. As now, we want to show, hopefully in the next conference, that by optimizing agentic systems according to our evaluation tool, be it using RL or using some other algorithms, we can get much better agents.
Okay, last question. Let's say your research agendas completely pan out in the next, 3 to 5 years. So like your PhD, maybe do an awesome postdoc, every paper you try to write goes exactly according to plan. What do you think that future looks like in terms of like what kinds of capabilities do we have now? What kinds of new things are we asking about in research? Like what does that ideal future look like?
Okay, I guess I can start. So I guess this is a very interesting question, because I previously worked on microservices, which like people was believing that would be like the future of software. But if you think about this, like let it be like multi-agent system or compound AI system, like they are basically the same principle, like same concept. The way I like to think about it is like there's like some graph structures of like ways to organize stuff, and then or like each node like does some functions of task. Before like LM takeoff, it was like some deterministic program. And then now like with LM, I guess you get more autonomy, letting the agent to do whatever you want to do. So I do kind of see like the future of like intelligent software to be like somewhat of that form, where you would have a lot of agent that's like working together to solve some tasks. But basically right now, like a very quick preview is that people are actually building agent in production, and then a lot of those systems looks like pretty simple at the moment. But I do think that will like pan out in down like 3 to 5 years, and then we will see like a lot of like more autonomous agent software system that's like working with each other. That's kind of like now the mature microservice system.
I'm personally very excited and bullish about multi-agent LLM systems. There are so many good reasons why, as these models get better and better, why every individual should have one or multiple agents. But now let's imagine a world where everybody has their own agents interacting on their behalf to do many different tasks. Now, one of your initial questions, what happens when these agents are collaborating together? What happens when these agents are not incentive compatible? There's so many exciting questions there. Game theory was a field basically created by von Neumann like 80-90 years ago. It has still so many unsolved problems. What happens if we try to do game theory for LLM agents? There are also so many computer system problems about multi-agent LLM systems. If there are many, like thousands, or basically if every individual employs multiple LLM agents for themselves, there are 8 billion humans in the world. So we will have many more agents. We will need to figure out good system solutions to handle these workloads. What will be like the optimal way to do inference for multiple agents? And again, how do we train them to be more collaborative? And maybe we will want our agents to be working against an adversarial to some other harmful agents. How do we make this happen? There's so many good questions there, and I think they'll also be still very relevant as these models get more and more intelligent in 5 to 6 years.
Cool. Well,
Yeah.
thanks for coming to talk with us. We have these little envelopes for you.
Thank you.
You can open them now.
Oh, okay. Oh no, okay. I don't want to like break this.
It's like
What is this? Wow. It's like the boat party thing that Dylan was talking
The
about.
first boat party, the original one.
I was very sad I didn't get an invite. Now I have
Now you have one.
I see. I was actually just messaging Dylan yesterday that like, why am I not getting accepted? Okay. Thank you so much. Yeah, it was a
Yeah.
pleasure.
Thanks, guys.
Thank you.